Science and Technology Physics class. My name is NC Joshua, popularly known as Oracle. Now we'll be looking at waves in pipes. Now there are two types of pipes. Remember that sound wave is a form of longitudinal wave, and a wave in pipe is a stationary wave. So now we are looking at waves in pipe. Now we have two types of pipe. We have the closed pipe and we have the open pipe. What's a closed pipe? Is open at one end and closed at the other end. The vibration also is open at one end and closed at one end. Is open at one end and closed at one end. So if I draw another example of a closed pipe, you see, open at one end, closed at the other end. I can keep drawing the next possible vibration. This is the least possible vibration you can get in a closed pipe. After this is the next. After this, there's another, there's another. I'll be showing you that in a moment. I'm trying to do a quick summary of the subject so that you can have a good knowledge of it. Now, in an open pipe, the pipe is open at both ends. That's an open pipe. The pipes are open at both ends. Now, this is the least vibration you can get in an open pipe. What is the next after this? So what I'm trying to say, it's open here, it's open here. If you put this in here, you see that we have it up to this point. Now the next one is closed, while the next one is open. So after this, the next one has to be something like this. Open. This is first, then it closes up. Second, then it closes up. Third. So after this is this, after this is this. But I'll be showing you how you can get all of this without even drawing them out. Now, there is something about the closed pipe. The closed pipe has a measurement of its length. Now, for instance, this point is called the antinode. This point is called the antinode. Why? Remember, this point is called the node. This point is called the node. This point is called the antinode. So for this case, we have the antinode, we have the node, we have the antinode, and we have the node. Now, remember when we're treating waves, we said the distance between the node and the antinode is lambda over 4. So the distance between here to here is lambda over 4. Why the distance between here to here is lambda over 4? Between here to here is lambda over 4. Between here to here is lambda over 4. I reiterate again. The distance between here to here is lambda over 4. Between here to here is lambda over 4. And between here to here is lambda over 4. So for this case, my L is equal to 3 lambda over 4, or I'll say 3 times lambda over 4, because I have 3 lambdas over 4. So L is now equals 3 lambda over 4. What's the next thing? What is lambda? Wavelength equals 4L for this case, while wavelength will be equal to 4L over 3 for this case. So I've been able to get my wavelength from this first vibration and wavelength for the second vibration. Now also I can get the wavelength for the third, for the fourth, for the fifth. But there's something about the frequency, because our major concern is the frequency of a closed pipe. Now the sequence of frequencies in a closed pipe is given as, I'll write it down so that it will make more sense, is given as F naught, 3F naught, 5F naught, 7F naught, 9F naught, 11F naught, 13F naught, 15F naught, and so on. It means if you take a look at all these numbers, you see that they are odd numbers only. There is no even number in them. They are just odd numbers. So the sequence in a closed pipe of its frequency is only odd numbers all through. Now, look at what I want to do here. If V equals F lambda, therefore F is equals V over lambda. Now, if F equals V over lambda, what is lambda? Lambda equals 4L, which equals V over 4L. So it means that the first frequency we could get in a closed pipe is V over 4L. I repeat again, or I reiterate again, the first frequency we could get for a closed pipe is V over 4L. So it means that this is the first frequency of a closed pipe is equal to V over 4L. Now, this frequency is called fundamental frequency. It's called fundamental frequency, or is called your first harmonics. It's called your first harmonics. It's called your first harmonics. Is the fundamental frequency and is the first harmonics. Now, there is something about the next one. Very simple. The next one will just be 3 times V over 4L, which is now 3V over 4L. Now, if you check, this is F naught. This is F naught here. That's why we call it 3F naught. So this is the second. Now, the third will just be 5 times V over 4L, which is now 5V over 4L. This is F naught again. V over 4L is F naught. So that's why we call it 5F naught. Look at it here. That's how I could do for all of them because I already know what F naught is equal to. So this is the first vibration in a closed pipe. This is the next vibration after this. And this next vibration, just as this is called our fundamental frequency and our first harmonics, is not called the second harmonics, it's called the third harmonics. There is no second harmonics in a closed pipe. If there was a second harmonics, you'll be saying 2F naught. So it is the first harmonics, this is the third harmonics, this is the fifth harmonics, this is the seventh harmonics, this is the ninth harmonics, and so on. But in terms of overtone, very important you know this. In terms of overtone, this is not your first overtone. This is your zero overtone. This is your first harmonics, but zero overtone. First harmonics, but zero overtone. F naught is your first harmonics, your zero overtone. Now, F3, remember, is not your second harmonics, it is your third harmonics. Your third harmonics, then your first overtone. Your third harmonics, but your first overtone. This is your fifth harmonics, but your second overtone. Now, this is your seventh harmonics, but your third overtone. This is your ninth harmonics, but your fourth overtone. Overtone follows sequence, but this one follows the odd number representation. So this is my 11th harmonics, but my fifth overtone. That's how you read your harmonics against your overtone. Now I will be showing you that for the open pipe as it is expressed in this way before I take some calculation questions for this case. Now let's look at the open pipe. What about the open pipe? In the open pipe, this is the antinode, this is the node, this is the antinode. Now what you have on top, some of you might be asking what is that? That's the tuning fork. I'll talk about that later, how you bring the tuning fork close to the mouth of the pipe, and because of resonation of air molecules, you have a loud sound. That point is called resonance. We'll talk about that later. But this is antinode, this is the node, this is antinode. This is the least possible vibration you can have in an open pipe. The next vibration after this is this. Now, this is antinode, the open space. This is the node. This is the antinode. This is the node. And this is also the antinode. Now, what about this? From antinode to node is lambda over 4. From node to antinode is lambda over 4. So how many lambda over 4 do we have in this vibration? So L is equals 2 times lambda over 4, where you have L is not equals lambda over 2. So you see the length is lambda over 2, therefore lambda equals 2L. But if you remember, for the closed pipe we did, for the least possible vibration, our lambda equals 4L. But for the open pipe, equals 2L. Now, if you come over here to check it out, you see we have here to here is lambda over 4, another lambda over 4, another lambda over 4, another lambda over 4. So we have 1, 2, 3, 4. So I have 4 times lambda over 4. This cancel this. So I have L is equal to lambda. L is equal to lambda. So I could do another vibration for an open pipe, but I'll be stopping here. Why? Because I could help you further by letting you know that the sequence of an open pipe, the sequence for an open pipe the sequence of the frequencies of an open pipe is given as, I will list it out here, F naught, 2F naught, 3F naught, 4F naught, 5F naught, 6F naught, 7F naught, 8F naught, and so on. But rather, remember in the closed pipe, it was F naught, 3F naught, 5F naught. So here is just odd numbers, but in the open pipe, it's both odd and even numbers. Now, what about here? Now, if lambda equals 2L, recall that V equals F lambda. Then what about the frequency? The frequency is now V over lambda. So the first frequency, which is the F naught, is now equal to V over, what is lambda equal to? 2L, 2L. This is the first fundamental frequency. But for this case, what will you now have? We now have V equals F lambda, F equals V over lambda. Therefore, F is equal to V over lambda equals L, V over L. This is the second frequency for this case. This is two of this. This is two of this. Say, I don't understand. Look at it. Let me do it here so that you just see it at a sketch. Let me do it here. F naught is equal to V over 2L. Therefore, X is equal to V over L. First multiply that, you have F naught times V over L is equal to, divide by V over 2L is equal to X. That's what you'll be having. So we have F naught times V over L times 2L over V equals X. So you should have that. V cancels out V, L cancels out L. So you now have therefore 2F naught equals X. So you can see that F equals V over L. V over L, which is F, is twice. Twice of this, or two of this, is equivalent to one of this, or is equivalent to this. So that's why we said it is F naught, it is 2F naught, it is 3F naught. So that's the progression you have in an open pipe, unlike a closed pipe that are just full of what now? Odd numbers. Now, let's see this in terms of harmonics and overtone, harmonics and overtone, and overtone, just as we have over there. This is now your first harmonics or your fundamental frequency, while this is your zero overtone. This is your second harmonics, your first overtone. This is your third harmonics, your second overtone. This is your fourth harmonics, your third overtone. Just like that. That's how it goes. But remember, it's different from this case. Why? Because the sequence here are odd numbers, while the sequence here are both odd and even numbers. Thank you. Now we'll be looking at some questions in pipes. Now I have four questions written here. We'll still be doing more questions, but most of these questions are questions that will help you tackle other questions at your own leisure. Now, the first question says, if the fundamental frequency of a closed pipe is 2 Hz, calculate the frequency of the sixth overtone. The sixth overtone. Remember, we're dealing with a closed pipe, and the frequencies of a closed pipe is given as F naught, 3F naught, 5F naught, 7F naught, 9F naught, 11F naught, 13F naught, 15F naught, 17F naught. Just that. Okay, so now this is 17F naught. So we have it in that manner as in a closed pipe. But remember, this is your first harmonics, 0 overtone. F naught is our first harmonics, 0 overtone. So this is our first overtone, second overtone, third overtone, fourth overtone, fifth overtone, sixth overtone. So this is our sixth overtone. That's what we are mindful of. So our sixth overtone equals 13F naught. Therefore, the frequency will be equals 13 times. What's our fundamental frequency? 2. 13 times 2. So the frequency of the sixth overtone will be 26 Hz. Now, let's see question number 2. Question number 2 says, if the frequency of the 11th overtone is 60 Hz, calculate the fundamental frequency. Let's add something here. If the frequency of the 11th overtone of of an open pipe. So let this be for an open pipe. If the frequency of the 11th overtone of an open pipe is 50 Hz, calculate its fundamental frequency. So how do you do this? Remember, for an open pipe, the sequence of frequency is F naught, 2F naught, 3F naught, 4F naught, 5F naught, 6F naught, 11F naught, 7F naught, 8F naught, 9F naught, 10F naught, 11F naught, 12F naught, 13F naught, and so on. Now this is 0. This is first harmonics, 0 overtone. Remember, we are looking at the 11th overtone. So it is 0 overtone, first harmonic. So this is 0 overtone, first overtone, second overtone, third overtone, fourth overtone, fifth overtone, sixth overtone, seventh overtone, 8, 9, 10, 11. So this is the 11th overtone. So 11th overtone is equals 12F naught. So therefore, we have 50 Hz equals 12F naught, where F naught, fundamental frequency, is what we are looking for. So therefore, F naught is equals 50 over 12. That becomes 4.16 hertz. That's the answer to that question. Now let's look at question number 3. Question number 3 says a closed pipe at one end is 1 meter long. The air in the pipe is set into vibration and the fundamental frequency is 85 Hz. Calculate the velocity of sound in air. Remember, there is a keyword here, fundamental frequency. Now the question is, what is the fundamental frequency for a closed pipe? Remember, fundamental frequency of a closed pipe is 4V is V over 4L. Remember, I did that in our last video, is V over 4L. This is the fundamental frequency for a closed pipe, but for an open pipe, fundamental frequency is V over 2L. So if this is our fundamental frequency, we are asked to calculate for the velocity of sound in air, that's V. So it means, what's our fundamental frequency? Fundamental frequency is 85. So I have 85x is equal to V over 4 times, what's the length of the pipe? Times 1. So I have fundamental frequency, sorry, the speed of sound is equals 85 times 4. So that will now give us 0, 2, 32 plus 2, that's 36 meter per second. So we have V is equal to 340 meter per second. Now let's look at this question number 4. Question number 4 is for question number 3. Question number 4. Question number 4. But in case it was not the fundamental frequency, let's assume it was the second vibration. Remember, for a closed pipe, the next vibration will be 3 F naught. So here will be 3V over 4L. But that's not the question that we have. Now let's look at question number 4. Question number 4 says the frequency of the note is dash. Remember, this pipe is open at this end and closed at this other end. Hence, it is a closed pipe. Therefore, remember how I taught you to calculate for a closed pipe. What is the length in this closed pipe? This is antinode, this is node. This is antinode, this is node. This is antinode, this is a node. So how many node to antinode do we have in this length? It is 1, 2, 3, 4, 5. So L is equal to 5 times lambda over 4. Remember, antinode to node is lambda over 4. So L is equals 5 lambda over 4. They are asking us to find the frequency. Now recall that therefore, what is lambda? Wavelength is equals 4L over 5. If this is wavelength, recall that V equals F lambda. If V equals F lambda, that means F is equals V over lambda. Therefore, F equals V divide, what is lambda? Lambda is 4L over 5. So F is now equal to V times 5 over 4L. F is equal to 5V over 4L. That becomes the right answer to this, which is 5V over 4L. That becomes the correct answer. Thank you.